Hi, I am Amy Swartz, Preservation and Programs Director at Historic St. John's Church. Today I'm speaking with Wilson Enochs. Wilson is the owner of J.W. Enochs Construction. He is the general contractor for Project Redcoat here at St. John's Church. I'm going to pass the mic over to Wilson now, and he's going to tell us a little bit about our newest project, Project Redcoat.
Thank you, Amy. Well, the foundation systems here at St. John's were probably coated in the 60s and 70s, and later, possibly, with a latex type paint. And it was a reddish brown, kind of matched the brick. And this scope of work removes all that old paint. Well, really, truly the first step is to protect everything around it. But we used a system that is made by a company called KEIM, K-E-I-M, and they have a complete array of products. They are really focused on the historic preservation market, and we use their products to remove the existing paint. The existing paint was causing problems which we've seen before in historic structures. It really causes moisture that's absorbed by the wall to continue up the wall. It can't find an evaporation point. That creates numerous problems and eventually is a detriment to the brick structure. So in removing this paint, we are going to get back down to the original brick substrate, and it should help preserve this structure. The next step is to go back and address all the joints that aren't properly filled. There are quite a few that this being really an older structure, they're lime-based mortars that are pretty soft. As they absorb moisture and go through freeze-thaw cycles, they basically degrade. We went back through and pointed for pretty much 2/3 of the building to fill those joints. We raked out any of the soft mortars to about 3/4 to an inch and then refilled the joints so that we now have a solid substrate for the paints that are getting ready to come, and they're not really paints in the normal sense. They're all designed to be air permeable. Again, KEIM, K-E-I-M, provides a whole series of coatings that allow air and moisture to pass through the wall. They also are hydrophobic so that water just landing on them sheds off, which is advantageous as well. But they're somewhat similar to the old renderings that were used throughout Europe. And it's a 3-step process. The first coat is it's really an agent to make the absorption rate on these masonry surfaces, which are various ages, consistent. The second, which is called a grob, which is a fairly thick coating. All these are lime and mineral based. They don't have any latex in them at all, so they're not similar at all to what most people are used to seeing from modern paints. That helps create a good substrate for the final coat, which is a coating called Solidit. All these coatings work well together, and they carry a fairly substantial guarantee. And by virtue of using one company's systems start to finish for the removal through the finished paint, we have confidence that they're all compatible. This, to a great extent, was uncovered by the archaeologists who excavated in the area where we were getting ready to work. They remove soils down to what is the bottom layer of the wall, and there is no foundation of sorts, or corbelling is what they used to do in the 1700s, where they would widen the wall out as it came down to bear on the soils. So in the cases where we're getting ready to reconstruct old piers, the pier dimension was continuous all the way down and sitting on native soils. I think one of the things that's made it last as long as it has here is, as you can see, we're on the top of a hill. Soils don't get as saturated up here. Everything drains pretty readily, so I think that ground was stable for many years. And all it would take is a slight change in those soil conditions to cause that twisting. If something settled on one side and didn't on the other, then you can get this twisting effect. And it has cracked some of the existing brick. Our intention, our directive at this point, is to go ahead and disassemble the wall in the affected areas, put in a concrete foundation, and then reconstruct the wall with as much of the brick as we can salvage. Some, of course, are cracked because of the twisting. And fortunately, the church has been smart to put away whatever brick they've found over the years, and there's a pretty substantial stock in the basement area. In the 1740s portion of the structure, and in a lot of the other areas, it's typical construction of that era. There is a sill plate that's probably 5 inches tall and 8 inches wide. Over on that far side, it has deteriorated to some extent, and the fix there is it's not impossible, but it takes taking things apart. Some time ago, and I don't know exactly who did it, but there were some shores inserted on the inside to carry the floor joists, so it took pressure off of that sill plate at the outside wall. Those shores are still in place and for the most part intact. Where they bared on a ledge of brick, though, they had been wicking moisture, and the bottom of those boards is now deteriorated. Part of the directive on the plans is to use epoxy anchoring systems to hold those shores in place. And another thing we'll do while we're down there is take those shores, wrap them in what is basically a rubberized flashing product, and tuck point or push mortar in between the shores and that brick sill so that the brick sill will again support the joists above and take some of the pressure off the sill plate at the wall itself. There are a few other minor fixes that are specified on these plans. Partial reconstruction of a set of stairs over on the Broad Street side. That will also add some foundations to the brick piers that are supporting it. A little bit of woodwork in and around the door area underneath. There are a couple of walls underneath too where the mortars have deteriorated pretty badly, and we will reconstruct and repoint those areas. That's pretty much the scope of work. Well, part of the work is very close to what is an existing grave. Its headstone being right adjacent to this window behind me, and the footstone right at the edge of that step system. So we wanted to make sure what we did in the way of reconstructing this portion of the wall, and you can see the cracks through the wall next to the downspout, didn't get into a gravesite. They did a pretty substantial excavation, a lot of which is covered up with plywood right now, both inside and outside, and they didn't find a lot. So we're well above the burial elevation that's associated with that headstone, and we don't really expect to run into a whole lot of stuff. I know that this portion of the building was built in the teens or 20s, and it could be spanning out over what was once part of the cemetery yard. So it's appropriate to check, because it could be that we're covering up something or digging into something that's important. We certainly want to make sure that the archaeologists are aware of it. But fortunately, they didn't find a lot, so I think we're in good shape. We'll be very tentative in our digging.
Wilson, thank you so much for your time today. This has been really interesting, and we really appreciate you giving us some insight into the project. We're excited to follow it, and we'll be definitely giving updates on our website, on our YouTube channel, and our Facebook page, so definitely check those out. We want to extend a special thank you to the financial supporters for this project: the Robert G. Cabell III and Maud Morgan Cabell Foundation, the Roller Bottomer Foundation, the Williams H. John G. Emma Scott Foundation, the Virginia Sargent Reynolds Foundation, the Richard S. Reynolds Foundation, the Titmus Foundation, and the Cecil R. and Edna S. Hopkins Family Foundation. And thank you to all of our individual donors as well that have made this project possible.